I want you to solve this equation, and if you know how to add fractions, this is going to be a piece of cake. So I'm going to give you the time in 3, 2, 1. Okay, I think you solved this question. This video's idea is not about how to add fractions like these. I'm talking about how these work, right? So we're going to talk about that today. Last video we discussed about the distributive property and how it works technically behind the scenes. Alright, so how does this work? I believe this also uses the distributive property in a secretive manner. And there are many ways to think of the same thing in mathematics. But I can also think the same thing how like adding this in the way of the distributive property. So I thought about this and I like how it turns out, and because of this, like distributive property is one of my favorite things in mathematics. It's like everywhere, pretty much everywhere I see. All right. So let's try adding this, shall we? All right, let me try making this small. Wait, why is it not working? Oh, oopsie. All right, let's make this small. All right, I can simplify 2 by 12, right? If you don't know what simplifying is, that I'll turn this 12 into 6 times 2. Yeah, it's 12. Now I know 2 by 2 is 1, and there's a 1 of course being multiplied, so 2 by 2 1, so it will be 1 by 6 into 1, which is 1 by 6. So we're gonna cut like this and we get what? We get the simplified form 1 by 6 plus 2. I think this is much simpler. Alright, let's try adding it. Alright, what should we do to add this? You might have seen in schools, that you multiply this, right? Multiply that, you get this, and you multiply that to get this 12, and multiply like this to get 6. Now, how does that work? It's actually just using LCM technically. So what it's doing is 1 times 1 is 1, right? We are not gonna like add something, right? We are not gonna multiply this fraction, right? We are gonna use the LCM to make this the denominators of these two fractions the same, right? 2 is 2 by 1. Yeah, that's also a fraction. So I'm gonna multiply this by 6, and this also multiply by 6. The numerator be multiplied by 6. Why? Because 6 by 6 is 1. So you might be thinking, alright, so no changes, what's the deal? We can manipulate this technique to get what we want. Alright, so what it's saying is just this 1 plus 12 by 6 isn't the same thing what we got. It's just that's how the algorithm goes, that's how the pattern goes. That's why I think most of the time in schools we learn this technique, because we at the time we don't know, like we didn't know that this LCM stuff existed. So yeah, if you don't know LCM, it's to find the lowest common multiple. So from 6 and 1 to get 6, from 1 you need to multiply 1 by 6 to get 6. So those are the least common multiple. So that's what is happening. So yeah, that's what's happening. Alright, let's say 1 plus 6. Now I'm not gonna say, yo, these are too common, and I'm not gonna say, oh, sorry, it's not 1 plus 6, it's 1 plus 12. I'm not gonna say, oh, because if these are common, we just write this, right? I'm not gonna say that, and here's a good reason. It doesn't feel intuitive, you know? And yeah, if you really think about how fractions work using a circle and making pieces and adding fractions with those, it makes sense, right? But I'm not always thinking about circles, right? So I'm gonna use the distributive property to understand this, right? Like without charts or anything. So this is bisets, this is bisets. Alright. One common thing you're gonna see is that 1 into 1 by 6 plus 12 into 1 by 6. So 1 by 6 is multiplied. They are common. They are what? Common. I think you heard this, right? Yeah, we use common things to distribute out. Distributive property. Amazing. And you might be thinking, oh, it's 1 by 6, not anything like whole or natural or integer. I mean, what it should be? If it's anything is common, if any number is multiplied or common, I can distribute it out, right? Now you can also represent this algebraically, right? You have seen this, right? A n plus b n gives me this, right? Can n be 1 by 6? And 1 can be a, b can be 2. Will this work? Think this out. If you're not convinced, it can work. So I can distribute the 1 by 6 out. That is amazing. So I get 1 by 6. Then that's multiplied by 1 plus 12. Sorry, what's happening? 1 plus 12. Wow. We just distributed the thing out. Alright, what are we looking here? So we got this, right? In general terms, we would say 1 plus 12 by 6. You might be saying, baby, the 6 is not under there. Don't worry. We're going to think about that soon. Alright, so that's 1 plus 12. That's happening here. Same thing is here. Okay, same thing is here. Now, what is 1 by 6 into 1 plus 12? If I can think like 1 plus 12 is equal to v, so if that's 1 into v, right, 1 into v by 6, then that's also, let me just, into 1, right? It's multiplied. 1 into v is v for me, right? And that's 6 into v, 6 into 1 is 6. And what the heck is v? We are gonna substitute that. Wait, did we get that thing? Yes, we did the same thing with the help of the distributive property. This is absolutely amazing, my people. Alright, this is amazing. So now let's find this out. It's 13 by 6. Now you can go ahead and find its decimal form, but I'm not gonna do that. That's where I'm gonna end. That's the whole point of the video. So yeah, I think you'll learn something new about the distributive property, a new way to think the distributive property. It's not totally new, but I think it's like, oh, well, 1 by 6 we can multiply, like distribute it out. Yeah, think maths like that. Think of what you know, the definitions, what you have learned, and try to use it everywhere and try some convenience in it. So that's all for my video today, and thanks for watching. I hope you learned something valuable today. Bye.